Hello, here we have example 5 of multiplying and dividing rational expressions. We're moving on to division, and we're going to start with monomials. So with division, it's very similar to multiplication, but the difference is you change the division symbol to a multiplication symbol and then take the reciprocal of the second fraction, the fraction you're dividing by. That fraction you're going to flip. You're going to take the reciprocal. So let's rewrite this by taking the reciprocal. We're going to rewrite the first fraction, 2a to the third b over 7b to the fourth. No change. But now we're going to change division to multiplication. We're going to take the reciprocal of the second fraction. So we're going to put 14b over a squared. And now we can go ahead and multiply. But remember, we need to reduce first. So we're going to check the numerator and the denominator to see if anything reduces. Now, I've got 2 in the numerator, but there is no even number in the denominator, so it does not reduce. But I have an a to the third in the numerator and an a squared in the denominator. So the smaller a to the second is going to reduce completely and leave me with 1. Now, a to the third, that's going to reduce by 2 of them. So the 3 reduces and we're going to be left with a to the first power. Now, for 14 and 7, they both reduce by 7. So this is going to reduce and become 1. This is going to reduce and become 2. And then I have b times b. I have 2 b's, or b to the second. That's overall in the numerator, and b to the fourth in the denominator. So I'm going to reduce both of those b's, and since that was 2 b's that I reduced, 4 reduced by 2 b's, that's going to be leaving me with 2 right there. So now I can go ahead and rewrite this. I have 2 in the numerator. I have a to the first, or just a, over 1, which I don't really need, and then b to the second, times 2, and that's the only thing that's there, just a 2, over 1. And now we're going to multiply across. 2a times 2 is going to be 4a, so we're going to have 4a over b squared times 1 is b squared, and that is our quotient. That is our solution. Okay, so here we have example 6 of multiplying and dividing rational expressions. We're moving on to division of binomials. And remember, first we need to change division to multiplication. So we're going to rewrite this. We're going to leave the first fraction the same, so equals 6x plus 12 over 20x minus 45. No change. But we're going to change division to multiplication, and we're going to take the reciprocal of the second fraction. So we're going to say 4x minus 9 over 2x plus 4 for our second fraction. And now we factor everything that's factorable. The first binomial, 6x plus 12, we can factor as 6. So we're going to put 6, open parentheses, x plus 2. Because 12 divided by 6 is 2. And then 6x divided by 6 is just x. Over 20x minus 45. I can factor a 5 out of both of these terms. So we're going to factor a 5, open parentheses. 20x divided by 5 is 4x, minus 45 divided by 5 is 9, close parentheses, times 4x minus 9. There's nothing to factor there, so we're going to leave it alone, over 2x plus 4. I can factor a 2. So we're going to write 2, open parentheses, and then 2x divided by 2 is x. Positive 4 divided by 2 is a positive 2. Okay, so now we factored everything, and now we check where can we reduce. So notice I have a 6 and a 2. I have a 6 in the numerator, 2 in the denominator. They both reduced by 2. So this reduces by 2 and leaves me with a 3. This reduces by 2 and leaves me with a 1. Then I have x minus 2 and x minus 2. Both of those are going to reduce. Next, I have 4x minus 9, but I also have a 4x minus 9 in the denominator, so those are going to reduce. So now let's write what's left. I have a 3 in the numerator, 3, over 5 in the denominator, times, there's nothing left here, so we have a 1 over, again, there's nothing left here. Everything's been crossed off, so we just have a 1. So 3/5 times 1 over 1, that's just going to be the same thing. That's just going to be 3/5. And that appears to be our quotient. So that is the simplified form of our original problem.